How UK cloud and data centers actually work. When people talk about cloud computing in the UK, they often describe it as something abstract, data floating somewhere, services running in the background, systems that feel detached from physical reality. In practice, cloud computing in the UK is deeply physical. It depends on buildings, power stations, fibre networks, cooling systems, and people operating complex facilities around the clock. This video explains how cloud and data centers actually work in the UK, where they are located, who runs them, how they are connected, and why decisions around cloud infrastructure are shaped as much by power and regulation as by software. What a data center actually is. At its simplest, a data center is a controlled environment designed to run computing equipment continuously. Inside a data center are racks of servers, storage systems, and network equipment. These systems generate heat, consume large amounts of electricity, and must remain operational at all times. As a result, data centers are engineered environments rather than ordinary buildings. A modern UK data center typically has multiple independent power feeds from the national grid, large battery systems to handle short interruptions, and on-site generators to provide backup power. Cooling systems maintain stable temperatures and humidity. Physical security is strict, often involving layered access controls, surveillance, and on-site staff. Downtime is expensive and, in some cases, unacceptable. Many services hosted in UK data centers are part of critical national infrastructure. Where UK data centers are located. Data centers are not evenly distributed across the UK. The largest concentration is in and around London, particularly West London, Slough, Docklands, and along the M4 corridor. This clustering exists because of access to fibre networks, proximity to internet exchanges, and historical development. Slough, for example, hosts one of the highest concentrations of data centre capacity in Europe. Docklands developed as a data centre hub because of its proximity to financial institutions and international connectivity. Smaller clusters exist around Manchester, Leeds, Birmingham, and other regional cities, but London remains dominant. Location matters because latency, connectivity, and power availability all affect service quality. Power as the main constraint. Power is the single most important constraint on data center growth in the UK. A large data center can consume tens of megawatts of electricity. That is comparable to a small town. As demand for cloud services grows, the availability of grid capacity has become a limiting factor. In some areas, particularly around West London, new data center developments have been delayed or restricted because the local electricity infrastructure cannot support additional load. As a result, cloud providers and data center operators increasingly work closely with national grid, local distribution network operators, and planning authorities. Energy efficiency, renewable sourcing, and load balancing are now central considerations in cloud infrastructure planning. Who owns and operates data centers? Data centers in the UK are owned and operated by a mix of organisations. Some are operated by specialist colocation providers such as Equinix, Digital Realty, and Telehouse. These companies provide space, power, cooling, and connectivity, while customers install and operate their own equipment. Others are owned directly by cloud providers. Amazon Web Services, Microsoft Azure, and Google Cloud operate their own facilities designed specifically for their platforms. Large enterprises, banks, and government departments may also operate private data centers, although many are moving towards colocation or cloud models. Each model has different trade-offs in cost, control, and risk. How cloud providers use data centers. Cloud providers do not operate a single data center per region. In the UK, major cloud platforms operate multiple facilities grouped into regions and availability zones. For example, AWS operates the London region with multiple availability zones, each located in a separate physical facility. This design allows services to continue operating if one data center fails. Applications can be architected to run across zones, increasing resilience. However, this also means that cloud services are tightly coupled to specific geographic regions. Data residency requirements, latency, and regulatory constraints influence where workloads can be placed. Inside a cloud region. Within a cloud region, infrastructure is highly standardized. Servers are deployed in large numbers, often with custom hardware designs optimized for specific workloads. Networking is software-defined, allowing traffic to be routed and controlled centrally. Storage systems are distributed across multiple facilities to provide durability. Data is often replicated automatically to protect against hardware failure. From a user perspective, this complexity is hidden behind APs and management consoles. From an infrastructure perspective, it requires careful orchestration and monitoring. Connectivity between data centers. Data centers are connected by high-capacity fiber networks. Cloud providers operate private fiber networks linking their facilities. These networks bypass the public internet for internal traffic, improving performance and security. Colocation facilities are connected to multiple carriers and internet exchanges, allowing customers to choose how their traffic is routed. This dense interconnection is one reason why London is such a powerful cloud and data center hub. Public cloud in the UK. Public cloud adoption in the UK has accelerated across both private and public sectors. Government departments use cloud platforms through procurement frameworks such as G-Cloud. Local authorities, NHS trusts, and agencies increasingly rely on cloud-hosted services. In the private sector, banks, retailers, media companies, and startups use cloud platforms to scale services and reduce infrastructure management overhead. Despite this, cloud usage is often hybrid. Many organizations run a mix of cloud services and on-premises systems. Why everything is not in the cloud? Not all workloads move to the cloud. Some systems have strict latency requirements, regulatory constraints, or legacy dependencies that make cloud migration difficult. Others are tied to specialized hardware or industrial control systems. Cost is also a factor. Cloud services trade capital expenditure for operational expenditure. Over long periods, certain workloads can be cheaper to run on dedicated infrastructure. As a result, UK infrastructure remains a mix of cloud, colocation, and private data centers. Security and compliance. Security is a major driver of cloud design. Cloud providers implement extensive physical and logical security controls. Facilities are monitored continuously. Access is tightly controlled. Systems are designed to isolate customer workloads from one another. Compliance with standards such as ISO 27001 and sector-specific requirements is common. Cloud providers publish extensive documentation to support audits and regulatory oversight. In the UK, data protection law influences how data is stored, processed, and transferred. Cloud providers operate UK-based regions to meet data residency expectations. Operational resilience. Resilience is a central concept in cloud and data center operations. Redundancy exists at every level. Power feeds, network links, cooling systems, and hardware components are duplicated. Monitoring systems detect failures and trigger automated responses. Despite this, failures still occur. Outages can result from software bugs, configuration errors, or external events. The goal is not to eliminate failure but to limit its impact. UK regulators increasingly require organizations to demonstrate operational resilience, particularly in financial services. Environmental impact. The environmental impact of data centers is a growing concern. Power consumption, water usage for cooling, and land use all attract scrutiny. Cloud providers publish sustainability reports and commit to renewable energy sourcing. In the UK, planning permission for new data centers increasingly considers environmental factors alongside economic benefits. Government and public sector use. The UK government is both a regulator and a major user of cloud infrastructure. Departments such as HMRC run large-scale transaction processing systems that rely on cloud and data center infrastructure. These systems must handle seasonal peaks such as tax deadlines without failure. Shared platforms reduce duplication, but increase dependency on underlying infrastructure. Why cloud feels abstract but is not? Cloud computing feels abstract because complexity is hidden. Behind every virtual machine, storage bucket, or managed service is physical infrastructure operated by engineers, supported by power grids and fiber networks. Understanding this physical reality helps explain why cloud services have regional limits, cost structures, and failure modes. Closing perspective. UK cloud and data center infrastructure is a blend of physical engineering, software systems, regulatory oversight, and operational discipline. It is shaped by power availability, connectivity, risk management, and long-term planning rather than speed or novelty. Understanding how cloud and data centers actually work provides context for modern digital services and explains why infrastructure decisions are cautious, deliberate, and often invisible. In the next video, we will look at how digital identity and authentication systems operate in the UK, and why trust is treated as infrastructure rather than a feature.